Today we're going to start a new unit on systems. So our first video is going to talk about what a system is, how we know what a solution is, and how we can find a solution by graphing. Alright, so to start, a system consists of two or more equations. Those equations could both be linear equations, they could be quadratic, they could be a combination of the two, they could be any type of equation that exists. So a solution to a system is an ordered pair that makes both equations true. So when we have our system that has two or more equations, they're going to have x's and y's in them. And so our solution to our system is going to be the x and y that are going to make both equations true. So in our very first example, we are going to see if the ordered pair 1, 4, so this point right here, we're going to see if it is a solution to this system. So if it's a solution, it makes both equations true. So in order to test that, I'm going to substitute in the 1 and the 4 into the equation to see if it makes the equation true or makes both sides equal to each other. Before we do that, we have to remember which number is which variable. So the first number is the x and the second number is the y. So we have to make sure we substitute into the correct place. So if we use the first equation, okay, so I'm going to use this equation right here, and I'm going to do the work down here. I'm going to substitute in 1 for x. So whenever I substitute something in, I'm going to put it in parentheses. So 1 goes in for x minus 3 times, there's a y, so the y was 4. And I'm going to check to see if that's negative 11. So I have 1 minus, and when I multiply, that's 12. Remember to use your order of operations or put it into your calculator in one step. So 1 minus 12 is negative 11. So the two sides came out to be equal. So it is true. So it works for the first equation. So 1, 4 is true for the first equation, but I need to make sure that it works for both equations. So now I'm going to plug it into the second one. I'll do my work over here. So negative 2, and then there's x, so I put a parenthesis, and I have to make sure I put in the correct number. So the x number was 1, plus 3 times, there's a y next, so that was 4, and now I'm checking to see if that equals 10. So I have, remember, multiply before you add, so negative 2 plus 12, and I'm checking to see if that's 10, and negative 2 plus 12 is 10, so it worked for this one as well. So 1, negative 4, if I was checking to see if it was a solution, yes, it is a solution. So yes, 1, 4 is a solution. Now, we haven't talked about how many solutions there are going to be yet. We just know that this is a solution. It works. If something is not a solution, that doesn't mean there aren't any solutions. That just means that what we have is not a solution. All right, let's try the next one. So we're checking to see if this ordered pair negative 3, 10 is a solution to this system. Now, notice my system this time, which, remember, it needs to be two or more equations. So it's two equations, and this time they're both quadratic. That doesn't matter, though. We're going to do the same thing. So to check to see if it's a solution, we substitute in negative 3 for x, because that's what the first number always is, x, and the second number is 10, so we're going to substitute 10 in for the y's. All right, let's try the first equation. So this time there's a y first, so I'm going to plug in 10. I like to use parentheses when I substitute it in. Equals, there's a 2, and then the x is next, so I'm going to put a parenthesis and put in the x number squared minus 8. So I check to see if that's true. So I know that negative 3 squared, I know that's 9, and I know 9 times 2 is 18. So I have 18 here minus 8, and 18 minus 8 is 10. Please feel free to put the 2 times negative 3 squared, make sure that's in parentheses, minus 8 in your calculator. Notice we get 10. You can put that in your calculator if you'd like. So we found that the two sides are equal, so negative 310 works in the first equation, but it has to work in both. So let's try the other equation now. So I'll do my work over here. So there's a y first again, so I'm putting in 10. Make sure you're careful what you're putting in for which variable. Equals, there's my x. So I'm putting in negative 3 for it. It has a squared. Minus 4 times, there's another x, so put a parenthesis and put in the negative 3 and plus 1. So let's see what this gives us. So the left side is 10 equals, and I could do that in my head. If you'd like to use your calculator, you can. So negative 3 squared is 9. 4 times 3 is 12, and a negative times a negative is positive 12 plus 1. So I have, let's see, 9 plus 12, that's 21 plus 1 is 22. So these are not equal, so it did not work for the second one. So is the ordered pair negative 310 a solution this time? No. So no. Negative 310 is not a solution. Make sure that when you have questions like this, you show the work of you substituting in and showing if the numbers are equal or if they're not equal. If you just tell me yes or no, I will not accept that for credit. You need to show me why or why not. So show your work. Remember, my answer for this one was no, negative 310 is not a solution. I did not say that there were no solutions. I don't know if there are. I just know that this one isn't. All right, now, quick question. What would you do if the ordered pair doesn't make the first equation true? Well, it has to make both equations true. So if I try the first one and it doesn't work, I can automatically say that no, it's not a solution. I don't need to even try the second equation. If it doesn't work for the first one, it doesn't matter if it works for the second one. Okay, so now that we've checked to see if something was a solution or not, we're going to actually find a solution instead of just checking it. So, since I told you the solution to a system was the ordered pair that makes both equations true, that means it's a point on both equations or both graphs. So if there's a point that's on both graphs, that means it is where they intersect. So the solution to a system is the point or points where the graphs intersect. Now, when we graph these by hand, or even if we get to use our calculator, I'm only going to ask you to graph lines. If I have other functions, quadratics, or absolute value, or exponential, I will graph those for you, and you'll just look at the graph. So let's solve this system by graphing. We might have to review how to graph lines again. So if I'm going to solve by graphing, I'm going to graph each one. So I'm going to start with y equals x minus 2. I'm going to graph it. Then I'm going to graph the other one, and I'm going to see where they intersect. So y equals x minus 2. Well, you need to remember that we have y equals mx plus b. And y equals mx plus b is slope-intercept form. So we can find the m, the slope, and the b, the y-intercept. So I don't have a number in front of x where the m is supposed to be, so that's a 1. All right, so here's how we graph again. First thing we do is we find the b, which is negative 2, the y-intercept, and we graph that, or we plot it. So on the y-axis, we find negative 2 and put a dot there. Okay, so you can find graph paper on Moodle. You can find it online. If you have a printer, you can print it. Otherwise, you just have to draw your x and x-axis, y-axis, and you're going to have to do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You're going to have to make tick marks. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You'll have to make that, and then you can draw it from there. All right, so I've got negative 2 as my y-intercept. The next thing I do is my slope, which is 1, but I need it to be a fraction, so I can do rise over run. So it's a positive 1, so rise 1, up 1. Run is a positive 1 also, so it's right 1. So up 1, right 1. And I'm going to go up 1, right 1 as far as I can. You do as far as you can on your graph too, and I need to go down 1, left 1. I got to go in the other directions as well to make my line. Okay, so there's my line. Okay, so now let's try the other one. So the other one is y equals negative 2x plus 4. So first thing, my y-intercept is 4. So on the y-axis, go up to 4. 1, 2, 3, 4. And my slope this time is negative 2. Don't forget to put a 1 underneath for slope. Now this time, my rise is negative 2. So down 2, right 1. Down 2, right 1. And all of a sudden, notice they intersect. I can keep going if I want, but as soon as they intersect, go ahead and draw your line. And the direction said to solve the system by graphing. So the solution to this system is the point where they intersect, and that point is 2, 0. And there's my solution in green. And it's 2, 0 because the x-coordinate went right 2, and then I did not go anywhere for my y-coordinate. I didn't go up or down, so 2, 0. Okay, so let's do one more example. So we're going to solve by graphing. So we're looking for the point of intersection. So where do they intersect? So let's say I start with this one. So y equals negative 3x plus 1. So my b value or my y-intercept is positive 1. So on the y-axis, I'm going to count up to 1. And then for my slope, it's negative 3. Make it a fraction by putting a 1 underneath. And notice the top number is negative. So I'm going to go down 3 and right 1. Down 3 and right 1. Down 3 and right 1. All right, now I need to go the other way just in case they intersect there. So go the opposite ways. So up 3, left 1. Notice they're still in the line. Up 3, left 1. Okay, now draw my line. All right, now I'm going to do the other one. Okay, so I'm going to do this one in red. So y equals negative 1/2 x minus 4. All right, the b value, the y-intercept is negative 4. So on the y-axis, 1, 2, 3, 4, negative 4. And my slope is negative 1/2. Now be careful because the negative's in the middle. So what I'm going to do is write it so the negative is with the top number only. So the bottom number is now positive. So that means I'm going to go down 1, right 2. And all of a sudden they intersect that quickly. So you don't have to draw any more points. Go ahead and draw your line. And let's see where they intersect. And that's our solution. So they intersect at 2, negative 5. So we went right 2 for the x-coordinate and then down 5 for the y-coordinate. So that's why it's 2, negative 5. That is the solution to the system. And if you would like, you could plug in the x number, which was 2 for the x's in the equations, and the y number is negative 5 into the equations, and you would see that it makes both equations true.